Hi, everybody. There was a request to solve one of the problems from the homework, so I would like to record this solution to section 2.7, number 3, which is a related rates problem. So let's begin by looking at this problem. At noon, ship A is 130 kilometers west of ship B. Ship A is sailing east at 30 kilometers per hour, and ship B is sailing north at 20 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? So the very first thing I think we should do is draw some pictures. Some north, south, east, west, the compass directions. And okay, we've got at noon a ship. I'll draw my ship A. Put a picture of a ship here. Is directly west of ship B to the order of 130 kilometers. And then ship A is sailing east, so I guess that's to the right. To the east at 30 kilometers per hour. And then ship B is sailing north at 20 kilometers per hour. Let me just make a quick note that your problems may be slightly different. These numbers in red are randomized in WebAssign so as to keep students from copying from one another. So if your numbers are slightly different, that shouldn't change much about the solution, other than, of course, the final answer and a couple of the calculations along the way. All right, so here's the basic setup. We've got the ship A and B that start off in this configuration, and then they start moving. So actually, let's draw another figure which has the ships as they've moved after a little bit of time. Ship A will have moved to the east to maybe say there, and ship B will have moved to the north to maybe say about there. And now we need to identify something about, let's see, how fast is the distance between the ships changing at 4 p.m.? Okay, so that means after 4 hours, they will have moved to a certain position, and we want to know how fast the distance between them is changing. So the distance from ship A at this moment to ship B at that moment, well, that's the distance here to here between the ships. So that must be a quantity that we care about. So now it's the time that we should probably start naming some important quantities. One that I think will be naturally important is I'm going to call it C of t for reasons that might be clear in a minute, be the distance from ship A to ship B at time t. All right. The reason that that is a quantity that we should care about is because we want to know how fast that quantity is changing at a certain time. So we want to know something about the derivative, the rate of change of that quantity. So let's name that quantity. Okay. Well, relatedly, we are given a speed 30 kilometers per hour of ship A and a speed 20 kilometers per hour of ship B. So maybe the positions of ship A and ship B, or the distances that they've traveled, maybe those are important quantities as well. So let A of t be the distance that ship A has traveled at time t, and let B of t be the distance that ship B has traveled at time t. Great, so now we have these quantities named, A of t and B of t, and it's important because we know that the derivative of A is 30 kilometers per hour, and we know that the derivative of B is 20 kilometers per hour. Great. So let's draw these things into our picture now. Let's use some color to really differentiate things. No pun intended. So if we color A of t orange, well, A of t will be this distance right here, the distance that ship A has moved from where it started to where it is at some particular time t. And maybe in red, we will let B of t, well, that's going to denote the distance that ship B has traveled from where it started to where it is at any given time t. So that'll be our B of t function. And finally, maybe in purple, we'll name this C of t, we'll indicate the C of t. That's this distance here. All right, so now what we'd like to do is find some sort of relationship between these three quantities. And if you look carefully, you might actually see that there should be a right triangle here, where C of t is the hypotenuse of the triangle, B of t is one of the sides of the triangle, and A of t is not quite one of the sides of the triangle. But if you remember that the original distance from where A began to where B began is 130 kilometers, then as ship A moves towards that position, I guess the distance from where ship A is to where ship B began, of course ship B is now up there, but where it began is right here, and the distance along this bottom side of the triangle, we'll call that 130 minus A of t. So now we see the three sides of a triangle that we can involve in the Pythagorean theorem. We'll see that the quantity 130 minus A of t squared plus B of t squared is supposed to equal C of t squared. And this should be true for every time t, including, of course, the time at 4 p.m. that we're interested in, but also at every time, which means that if we were to take the derivative of each side of this equation with respect to time, then we'd still have a true equation because this equation holds for all times t. So let's do exactly that. Since we know that rates are going to be important, let's take the derivatives of both sides of this equation. So we get d dt of 130 minus A of t squared plus B of t squared. And on the other hand, we're going to take the derivative of C of t squared. All right, well here then we're going to find that 2 times the quantity 130 minus A of t raised to the first. But then the chain rule says that we need to take the derivative of the internal thing inside the square also. So we'll end up with a negative dA dt, that is the derivative of the function a. And then we will add to this 2 times B of t times the derivative of b with respect to t. And then on the right-hand side of the equation, we'll have 2 times C of t raised to the first times the derivative of c with respect to t. All right, well, we can clearly see that there is a factor of 2 in every term here. So we can clean this up and say that 130 minus A of t quantity times negative dA dt plus B of t times dB dt is equal to C of t times dC dt. All right, and now it's worth identifying what are the quantities in this equation, what we know, what we're looking for, and what we can figure out. So let's work from right to left, because this dC dt, that's the derivative or the rate of change of C. Now remember, C is the distance from ship A to ship B, and we want to know how fast is that distance changing at a particular time. So this is really our goal, to find dC dt at a particular moment. Okay, C of t, that's this distance between the two ships at 4 p.m. I don't know that off the top of my head. We'll have to come back to that. But dB dt, well, that we know. That was given. That is the rate of change of ship B. That was our 20 kilometers per hour. And B of t, oh, well, I guess we can work this out. Because if we know the speed per hour, 20 kilometers per hour that ship B is traveling, and we know how many hours have passed from noon to 4 p.m., then we can work out exactly how far B has traveled. So that shouldn't be too hard. dA dt, this was given. This is, well, with a minus sign, our 30 kilometers per hour. That's part of the problem. We know how fast ship A is traveling. And then similarly, we can work out A of t if we know how fast it was traveling and how far it's been traveling for. And then I guess if we could work out A, then we could work out 130 minus A, and we could work out B, and so we would be able to figure out the C at the particular moment we're interested in. So let's do this working out now. This will be able to be worked out using A of t and B of t. So let's go do this working out over here on this side. So if ship A travels at, we said 30 kilometers per hour for 4 hours, then A of t is equal to 120 kilometers at 4 p.m. Ship B travels at 20 kilometers per hour for 4 hours. So B of t is equal to 80 kilometers at 4 p.m. So finally, we know that C of t squared is supposed to equal 130 minus A of t squared plus B of t squared. So at 4 p.m., C of t squared is equal to 130 minus 120 squared plus 80 squared, the quantities we had just above. We said that A of t was 120 and that B of t was 80. So we plug in 120 and 80. And we find that C of t is going to be the square root of 130 minus 120 will be 10, and we square that, and 80 squared. All right, let's simplify that. That's the square root of 100 plus 6,400. That is the square root of 6,500. And at the very least, I guess we can factor out a 100 from that. So we'll find that this is 10 times the square root of 65. And I believe that square root of 65 can't be simplified any further or easier. So we'll leave that there. And now we have all the quantities that we needed to work out in this equation. So finally, let's solve for our goal, our dc dt. dc dt is equal to 130 minus A of t times negative dA dt plus B of t times dB dt, all then divided by that C of t. And at the particular moment that we care about, we can plug in these values now. So we have 130 minus 120, that's our A of t, times negative the derivative of A, that would be negative 30, plus B of t we said was 80 times dB dt. The derivative of b was 20, since b's rate of change is 20. And finally, we divide by the c of t that we calculated, t times the square root of 65. Finally, let's clean that up just a little bit. 130 minus 120 is 10, so this will be negative 300. 80 times 20 is 1600. 10 times 65. All right, 1600 minus 300, I guess that's going to be 1300. Divided by 10 times root 65. And of course, there's a factor of 10 in there. So we'll call this 130 divided by the square root of 65. And the units should be kilometers per hour. Let's check that that makes sense given our calculations. 130 minus a of t, this would have been in kilometers, because a of t was measured in kilometers, 130 was a measure of kilometers. dA dt is kilometers per hour, that's a rate. B of t is a kilometers, dB dt is kilometers per hour. So the top units here in the numerator would be kilometers times kilometers per hour. And then that C of t, that's also going to be in kilometers. So then when we divide by kilometers, we're left with kilometers per hour as we expected. So that does make sense that these should be the units given our calculation, and we have a final answer for this problem. All right, I hope that that was helpful for you guys. Please feel free to ask more of these questions in the future, and I will do my best to provide solutions.